Question. As the CFB increase in size and reheat cycles are incorporated, some manufacturers add fluidized bed heat exchangers. Why? Answer: to enhance steam side heat pickup. As CFBs grow larger in size, the surface to volume ratio of the combustor decreases, whereupon the furnace water valve cannot meet the required evaporator duty. Under the circumstance, FBHCs allow incremental evaporative duty by passing a sufficient amount of recycled solids into the bundle. Question. Is this the only ground to favor FBHE? Answer. Besides performing the reheat duty, FBHE has another plus point. Means these heat exchangers work at very low superficial velocities, around 30 centimeter per second, and some designers believe that they are less prone to erosion than air in combustor evaporative panels. Question. What are the other reheat options for CFBs? Answer. Steam cooled cyclones, external heat exchangers, tube bundles in the backpass shaft, omega panels, wing walls in the upper section of the combustor. Question. Foster Wheeler has designed, erected, and operated several circulating fluidized bed units in the continental United States, firing a variety of waste fuels including anthracite, gum, petroleum coke, and tire derived fuel, in addition to normal coals. These units have accumulated many years of operation with high availability and low maintenance. What are the main design feature and components of FW CFB units? Answer. Balanced draft system, 100% natural circulation, high heat input startup burner located in the primary duct, fully water cooled air plenum, grid and furnace, directional air grid, fluidized bed stripper cooler for handling bottom ash, air shaft fuel feeders, steam cooled cyclone and inlet channel integral with the furnace, non-mechanical J valve in the recycle system, loop seal. And 10th point, conventional series or parallel pass HRA, heat area, tubular air heater. Question. What are the distinctive features of FWCFB process? Answer. Presence of pronounced bed with bed depth of 0.5 to 1 meter and relatively solid lean freeboard above it. Figure. And second point is distinct bed fluidized regime is achieved by using relatively coarse fuel and sorbent size distributions and a relatively low primary furnace zone velocity. Therefore, the bed does not require an additional coarse inert material such as rock or pebbles. This budget baggets the advantages of firing waste fuels with either high ash wise anthracite culm or very low ash such as petroleum coke. Higher solids residence time, lower solids loading through the HRA and downstream equipment, low erosion potential in the furnace and cyclone inlet, predictable thermal performance, simple controls. That's it. We can see the diagram. Comparison of fluidized regimes. FWCFB restricts fuel combustion within a bed depth of about a meter and thereby minimizing afterburning in the cyclone. Courtesy Foster Wheeler Corporation, New Jersey 08809 4000 USA. How USA dominate all fields. Okay. In this diagram we can see inlet of the primary air in bottom and FWCFB process is there in left side diagram, and right side fast bed primary air is inlet to the bottom of the boiler, secondary air is giving to the middle of the boiler, and solids feed into the bottom of the boiler. So the next question, what are the benefits of these conditions? Answer, predictable operating conditions, high fuel burnup efficiencies, high limestone utilization, low SOx, NOx and CO emissions, low maintenance, low production costs. Question, what is a directional water cooled air distributor? Answer, developed by Foster Wheeler for bubbling fluidized beds, BFBs, in early 1980s. The water cooled directional air distributor is formed of single outlet nozzle oriented in a specific pattern to direct coarse material towards the drain. The directional air nozzles are bolted to the integrally welded fins of the distributor floor. You can see in figure 1.6. The distributor floor and air plenum floor are formed by using the furnace front or rear wall tubes. Since the furnace and air plenum share the side water walls, there is no need to install high temperature expansion joint and thick refractory layer. We can see the directional water cooler air distributor in the diagram, courtesy Foster Wheeler Corporation, New Jersey 08809 4000 USA again. In this diagram we can see the boiler tube and insulation static layer is around the boiler tube and the air nozzles. We can see the cross section of air nozzle also. So the next question, how does the water cooled air distributor operates? Answer, the directional air distributor is formed of single outlet nozzle oriented in a specific pattern to direct coarse material towards the bed outlet drain. The pattern of the nozzle arrangement is vary depending on the nature of the fuel. For example, a fuel consisting of rocks and other tramp material will have a pattern that will give rise to least residence time for such substances. Conversely, a fuel which is either coarse or possesses a low reactivity will require a pattern of nozzle arrangement that begets the greatest residence time. The outlet of the nozzle are large, means approximately 13 to 25 mm diameter. The outlet branch of the nozzle discharge a large, almost horizontally jet of air, which effectively dislodges even large particles in its path. Any large or heavy material, small clinkers or agglomerators sink to the bottom of the fluidized bed. These particles are forcibly conveyed to the bed drain along a path detected by the nozzle pattern before they accumulate, diffuse, overheat, and or fuse as large masses. Question, why are nozzles with large single outlet are preferred to nozzles with multiple small openings? Answer, large dia nozzles are not prone to pluggage as a nozzle with small opening. Question, where is the directional air distributor installed and what is its utility? Answer, the directional air distributor is provided in the furnace as well as in the bottom ash fluidized bed stripper cooler. The unique directional distributor design continually removes oversized particles from the furnace into the ash disposal system and thereby ensures uninterrupted operation. This feature is particularly important for a large capacity AFBC unit that has a large plan area. Next question, is there any specific example attesting to the advantages of using directional air distributor in CFBs, burning waste or non-conventional fuels? Answer, the 20 megawatt AFBC boiler at the Manitowoc Public Utilities MPU, Manitowoc, Wisconsin, USA burns a combination of petroleum coke, tire derived fuel, and bituminous coal. Accumulation and nesting of wire from TDF has not been experienced. Wires accumulate to a maximum level which is below the nozzle discharge. Accordingly, wire pieces are found in the spent bed material, leaving the bed hash stripper cooler. Therefore, directional nozzles are decidedly effective in removing the wire originating from TDF. Similarly, after several months of operation, the NISCO AFB unit 2 into 110 megawatt Westlake Los Angeles USA has not experienced any fluidation problems in the furnace or the stripper cooler despite the high vanadium content in the delaying coke. This is distributed to the effectiveness of the directional distributors to dislodge any agglomerates that might have begun to form in the unit. Thank you.